Hello, ladies and gentlemen. Today we're going to talk about start our discussion about radicals. So the first thing you're going to do is we want to talk about the parts of a radical. So if you'll follow along on the Google slide that I've presented with you, you'll have these boxes. When I'm writing in, there'll be boxes you can type in. I need you to fill it out, and then at the end of the video, I'll talk about what you're supposed to do when you get done. All right. So in the first box where it says the nth root of a number, a can be written as the radical expression, the radical, and then the index of n, and the radicand, which is a. So in this first box, you're going to write index. Okay. Then the second box you're going to write, and that's going to always be the particular root you're looking for. Now, normally we would say square root, but as we go through the lesson, there may be other radical indexes we'll use as part of this lecture. All right, the actual square root sign is actually called a radical sign. So just write radical. So that's you'll hear me refer to a lot saying the radical. I'll say square root, but I do want you to understand that it's not always going to be square roots. And then a is your radicand. This is what you're trying to find the index or the root of. So it's radicand, radicand. All right. If there is no index, it can be assumed that n is equal to 2. That's the smallest root we can find. We don't have a square root of, a root of 1, because that means is whenever we're looking for, our index tells us how many times can we multiply the same number to get the number inside the radical sign. So that's why we say square root, because we're talking about what two numbers can we multiply to get the number inside the radical. Okay, if a radical has more than one root, the radical sign indicates only the principal or positive root. Now, when we get to algebra 2, we're going to deal with square roots or radicals with negative numbers, but for algebra 1, we're just going to stick with it being a positive root. So the next box asks you to fill in, list the first 12 perfect squares. So we're going to start with 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And then lastly, 12 times 12 is 144. Now, this should be a review of what you talked about before. And I'm going to show you a different way as part of this video as well. But for right now, just list those first 12 perfect squares. So the next section we want to talk about is perfect square roots. So basically, perfect squares means it's the same number multiplied times itself will give us another number. For instance, the square root of 16 is equal to 4. Okay. Now, on number 2, you notice that there's a number outside that's our factor that's outside of our radical sign. So that's not our index, because the index is going to be a smaller number. It's not going to be the same size as the regular numbers. So basically what that's telling us here is that we're going to have to multiply, sorry for that little update there. It's going to be 2 times the square root of 121, which we just found is 11. All right? So whenever you have a number outside your radical sign, you multiply that by the square root or the answer we get when we find the simplify the radical. So 2 times 11 gives us 22. All right? Then we move on to the number 3. All right? We have 6 times square root of 289. Now, I'll go ahead and tell you we didn't list 289, but 289 is, 17. Square root of 289 is 17. So it's going to be 6 times 17 equals 289. All right? Not 289, I'm sorry. Apologize about 102. Sorry about that. It's going to be 102, so give me 1 second to erase that. Sorry. Pen. 102. Sorry about that. And then lastly, number 4 was 3 times square root of 400, which comes out to be 3 times 20, and that gives us 60. Okay? So all these are fair game questions. You can either have a perfect square, and if you notice, all of the square roots that we determined were all perfect squares. Now we had to multiply by the factor, but on 2, 3, and 4, but number 1 was just find the square root. All right, so simplify non-perfect squares. So what I want you to do is, on a separate sheet of paper, we're going to come over here, if you'll bear with me. Give me a second. I apologize for my little colorful background, but this will give us a chance to do this. So I want you to make this sheet. I'm also going to make it in a Google Docs for you as well. All right, or rather a Google slide. All right, so 1 squared we said was 1. 2 squared we said is 4. 3 squared we said is 9, sorry. I'm just getting a little momentary lapse. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. 17 squared, we just said, was 289. 18 squared is 324. 19 squared is 361. And lastly, 20 squared is 400. Okay, sorry about that. All right, so I want you to make note of these and underline our perfect squares. Okay? So I'm going to refer back to this, so I apologize for going back and forth, but I did want to do this on a separate document. All right, so these are all the perfect squares that you should need for Algebra 1 and somewhat Algebra 2 as well. All right, so let's go back to the problems in the second set, which was simplifying non-perfect square roots. So, all right, so come back over here. All right, so the first thing we want to do is, because we've already identified these are non-perfect squares, but you always want to check and see if the number, in this case 32, if it's on our list. So again, we're going to go back to our list. And if you notice, 32 is not listed anywhere on this list. It's not anywhere, none of the underlying numbers equal 32 or are 32. So basically what that means is that we're going to have to figure out what we're going to have to do. So what you're going to do here for this is you're going to come over to the side, and you're going to take the first perfect square that, if you look at our list, the one that's slightly less than 32, which is 25. So you always start at the bottom of your list and find the perfect square that's slightly less than your perfect square, or your number that your radicand. Okay? So 25, if you notice on our list, 25 is the first one that's slightly less than 32. All right, so we come over here, and we say 32 divided by 25. Okay, 32 divided by 25, that's going to give us a fraction or a decimal. So we're going to say fraction. We don't want that. What we're trying to do is find the highest perfect square that will be a factor of this. So that means we're going to get a whole number. So if you divide 32 by 25, you'll see it's a decimal or a fraction. All right? Then we go up. We continue to go up the list until we get the highest perfect square. We always start at the bottom of the list because we want the highest perfect square, because we want our radicand to be as low as possible. Because I'm going to tell you right now, it's not going to, when it's not a perfect square, it's not going to be, there's going to be a radical sign left with a radicand. So the next one you notice is 16. It's 16. That's our next one. So come over here. Sorry. And do 32 divided by 16. All right, 32 divided by 16 is 2. So that means the highest perfect square that is a factor of 32 is 16. and the non-perfect square factor is 2. So we're going to come over here and rewrite our radical, and we're going to put 16 times 2. Now, I always put my perfect square factor first, and I'll show you why in a few moments. But to me, that makes a little more sense. But if you want to put 2 and then 16, that's fine. It'll still simplify the same way. All right, so now we find the square root of 16, which we've already said from our number 1. If we look up there, it's actually going to be 4. So I'm going to come down here, and I'm going to cross out 16. The reason I cross out my perfect square is that way I know that I found the square root of it, so I don't need to do anything else with it. 2 is not one of our underlying numbers, so therefore it's not a perfect square, so we're going to leave it inside our radical sign and put 2. And that's your simplified answer, okay? So again, this technique tends to work well with most of my students. However, I am including a video with it. If you have another way that another teacher taught you how to simplify radicals, I'm fine with that. I'm not picky, and I'm not going to trip if you do something. As long as it works, as I told you in class, as long as it works every time, I don't care how you find the answer. All right, so now let's come over to 180. We know 180 is not one of our underlying numbers, so we go back to our list. And I definitely advise you to have this list available to you when you're working out these problems. So 180, if you notice, is not one of my underlying numbers. The first perfect square that's slightly less than 180 is 169. So that's what we're going to start with. Okay? So we go back over here, and we're going to say 180 divided by 169. And that's going to give us a fraction, so we don't want that. Okay? So we don't want that. So the next one we're going to do is we're going to go to the next one, which is going to be 144. Okay? So we're going to say 180 divided by 144. Again, that's going to give us a fraction. Now, when these numbers are a little bigger, sometimes you got to go a long way. But for the sake of time, guys, I'm not going to. We're not going to go through all of them, but I do want you to do it on your own that way. So I'll go and tell you, if you continue going up the list, when you got to 180 divided by 36, that would have been 5. Okay? So you're going to rewrite your radical as 36 times 5. Square root of 36 is 6, so we just cross out that. 5 is not a perfect square factor, so we leave it as 6 times the square root of 5. So that's your answer there. All right? So hopefully no questions at this point. All right, so now we go back. We see 147. We go back to our perfect square list. We notice that 147 is not one of our underlying numbers, so it's not a perfect square. So 144 is the first perfect square that's slightly less than our number. So we're going to say 147 divided by 144. Okay, again, that would be a fraction or a decimal, so we don't want that one. The next one we'll do is 147 divided by 121. Again, that's going to be a fraction. We don't want that one. The highest perfect square is actually 49. Okay, and that's going to be times equals 3. So 147 divided by 49 is 3. So we'll rewrite our radical as 49 times 3. Okay, square root of 49 is 7, so we cross out 49, and then we have square root of 3. Okay, sorry about notifications. I'll make sure they're off for the next video. I apologize for that. So then that's our final answer for number 7. Number 8, again, we got 177, sorry. Just erase that, I'm sorry. So 175, the one that's slightly less than 179 is 169. That's going to be a fraction. We don't want that one. Okay, 175 divided by 144. Again, that's going to be a fraction. We don't want that one. All right. So I'll go ahead and skip to the one that actually is, which is 25. And that's going to be 7. Okay. So then we rewrite our radical as 25 times 7. Square root of 25 is 5, so write it right below it, and then rewrite our square root. Okay, so 5 times square root of 7. All right. Then we move on to the next one, which is 48. All right, so again, the highest perfect square is slightly less than 48 is 36. That's going to be a fraction, so we don't want that one. Then we got 48 divided by 25. Again, that's going to be a fraction. We don't want that one. The highest perfect square is actually going to be 16, and that's going to give us 3. So then we're going to say 16 times 3. So the square root of 16 is 4. Okay, so we put 4 and then square root of 3, and circle that. All right, and now our last example that we're going to do is, this time we have a factor in front of our radical, so that's going to change a little bit, but we're still going to find the square roots like we did before. So the highest perfect square that's slightly less than 54 is 49. That's going to be a fraction or a decimal, so we don't want that one. And then 54 divided by 36 is the next one. Again, that's a fraction. We don't want that one. So the highest perfect square is actually going to be 9. Okay? So we're going to have 2 square root and then 9 times 6. Okay? So that's actually our highest perfect square. All right? Because 54 divided by 9 is equal to 6. All right? So come over here. Square root of 9 is 3. So we're going to say, but when we make it 3, it's going to be 2 times 3 and then square root of 6, because square root of 9 is 3. So that we had to, when we brought it out before, we just put number, but now that we have a factor, we have to multiply the two numbers. So 2 times 3 is 6. So then that's going to be square root of 6. All right? So that's pretty much our lesson on the parts of a radical and how to find perfect square how to find perfect squares, the perfect square roots, and then non-perfect square roots. Okay? So if you notice the notes, it'll also say the same information. But again, whatever method you want to do, if another teacher taught you another method, I'm fine with that, so long as you get the right answer. All right, well, that's it for this video. I apologize, a little rusty. I didn't record a video in a minute, so you'll bear with me. But the next time, my notifications will be turned off, and you won't get any little updates. But thank you, and like I said, complete the problems that I've assigned in Google Slides. You'll do it the same way. I recommend using a piece of paper to figure out your square roots, and then when you have your answer, I'll have boxes. What you need to do is type in the information inside the boxes. I'll explain this in our Google Meets as well and show you a couple of examples. But basically what you're going to do is you're going to insert the radical, go to insert symbol inside Google Slides, and then you'll type in your number, then do insert symbol, find the square root sign, find that, and then put your number and your radicand that's still inside the radical sign, and that'll be your final answer. Okay? And if you're having troubles, you can always say 4 square root 4. You can actually write out square root and 4 square root 2, and I'll understand what you mean. But stay tuned for the next video, which will be adding and subtracting. So that will be our lesson for Wednesday. Thanks, and have a nice day. Bye.